Hello dear student, today we are going to learn about the Norton's theorem. Now before learning the Norton's theorem, you should know about the concept of the Thevenin theorem. Now what should we do in the Thevenin theorem? So in a Thevenin theorem, we have seen that if any network consisting of a number of energy sources and the number of the element which can be viewed from the open circuit terminal, then that network is replaced by a single equivalent network which consisting of a open circuit voltage source which is known as the Thevenin voltage source, which is in series with the equivalent resistance RTH. Means in a Thevenin theorem we have to first solve for the VTH and then to solve for the RTH, and VTH is connect in series with the RTH and then connect the load resistor RL across the your open circuit terminal A and B, and then find out the current I passing through the RL. That is the Thevenin theorem. Now what is the Norton's theorem? So suppose for any network, if you want to find out the current for passing from the particular element, then you can apply either a Thevenin theorem or either a Norton's theorem. So in a Norton's theorem, what we should do? So in a Norton's theorem, statement is like that, okay, if any network having a number of energy sources and having a numbers of the element which can be viewed from the open circuit terminal, then that network is replaced by a single equivalent current source ISC, which is called a Norton current, and the single equivalent resistance R equivalent, which is connected in parallel with the short circuit current source, and then the load resistor is connected across the terminal, and find out the value of the current I passing through the RL. That is the Norton's theorem. So see the difference between a Thevenin theorem and Norton theorem. In a Thevenin theorem we have seen we have to first solve for the VTH and then the RTH, wherever in a Norton's theorem you should first of all find out the ISC, that is the I and Norton current, and the R equivalent, and then make the equivalent Norton circuit. So now we have seen the Norton's theorem. So see Norton's theorem, one network is here and here a terminal A and B which is equivalent to ISC, which is parallel to the R equivalent, and then they connect the load resistor here which is a disconnected. So